This video will overview the terminology associated with oxidation and reduction, as well as give a little history of how we even got here in the first place. So once upon a time, there was a scientist who was also low-key a pyromaniac who was wondering, how can I make fire bigger? They recognized that fire was a chemical reaction, which means you started with something and ended with something else by some kind of a reaction occurring, but they didn't necessarily know what about the chemical reaction would be best to make fire bigger. And so they asked themselves, like, what chemicals would work best? At that time, they didn't really know what all of the elements were, like the periodic table didn't exist. And so they also didn't really have an understanding of what was in air. They just knew you could create different kinds of air from different reactions. So they did some other kind of reactions, created this specific kind of air, and then put this air with fire and realized the fire just exploded. It got way bigger, way faster. And so they decided to call this special kind of air oxygen. And they determined that the thing that's allowing the fire to happen is called oxidation. So how oxygen is working and making this fire bigger is whatever is oxygen. And so that's going to be called oxidation. They had no understanding of electron flow, hydrogen moving, what size the oxygen even was to be able to move or not move. So this was really just based on like observations at the time of, okay, oxygen's here, this leads to this, therefore this is oxidation. More experiments later down the line realized it wasn't just oxygen or that special air that was able to make a fire bigger. You could also, for example, expose it to hydrochloric acid and it's going to catch on fire. There's no oxygen present, but something about that is still allowing for fire to get bigger. So we can't really say that it's only because of something oxygen is doing, but whatever oxygen is doing, it's clear other chemicals and elements can do the same thing. So then they decided, they went even further down and they realized this is actually electrons moving. It's not the oxygen itself. It's just that oxygen has some extra electrons, which makes it easier for us to understand based on oxygen. But with hydrochloric acid, for example, it's still electrons moving to determine what's going on. Earlier on, researchers also decided, oh, maybe it's all because hydrogen's moving, or maybe it's because of something else moving. But the current consensus right now in science is that it is because of electrons moving, not because of anything else. The only thing that we're talking about when referring to oxidation is the movement of electrons. So they decided to keep the name oxidation, but what oxidation was even describing changed. And so now oxidation is when a molecule is acting like oxygen does in a fire. The electrons are lost from that molecule. So oxidation is the removal or the loss of electrons. In contrast, whenever you have one thing, you're also going to have something else occur within a reaction. So if something's losing electrons, something else has to gain these electrons. So if we go back to that, okay, this is pyromaniac, how do I make things bigger? Fire is a chemical reaction, cool. That means that the oxygen is going to have to do something to something else. And so the thing that oxygen is doing to something else, that other thing will have a reduced mass in the products from what it had on the reactant side. So if we're looking at fire and we see fire reacting with oxygen, we see on the other side, the oxygen has reacted with the thing that was making the fire. Now that thing that was making the fire has a reduced mass. Because of this reduced mass, they decided that it was a reduction. And so going back to just the initial, how these words came into play in the first place, oxygen reduced the mass of something else, therefore oxidation caused the reduction of a mass of something else. Makes absolutely no sense when we know what we know today in science, but that's what they were working with when they were working with it. And so they decided the mass that was lost was oxygen, whether or not that's actually accurate. And so more or less, they decided reduction is coupled with oxidation and they work opposite from one another. So oxygen does something to something else, and the something else is the other thing that's acting within this reaction. Later, they again realized it was electrons that were making the fire happen or making the fire bigger. And so we can't just talk about what oxygen is doing when we're talking about reactions. We have to focus on the electrons. So if we go back to oxidation, is how oxygen losing electrons during a fire, the thing that oxygen gives the electrons to has to gain the electrons or take the electrons from oxygen. And that, what used to be called reduction, is still going to be called reduction. We don't want to change the name of it. However, what reduction actually does is completely different. It has nothing to do with the size of a molecule or the mass of that molecule. It now has to do with the gain of an electron. Some teachers, some chemists may try to explain this as, oh, you're reducing the formal charge of the thing. It can get really complicated to understand all of those things, as like reduction is reducing something. It's not reducing the mass, which is why reduction happened in the first place. Don't get yourself confused trying to understand some random scientist's explanation of something. If you understand how we got to this word and what the word's definition actually is, everyone else's explanations matter none whatsoever. So then, if we're talking about a redox reaction, you always are going to have a oxidation with a reduction. And being able to track which is the oxidizer, what is oxidized, and what is reduced helps by remembering the whole electrons thing. And if that whole story doesn't stick in your mind, another way that you can remember this is by the phrase Leo the lion says grr, where Leo, L-E-O, stands for the loss of electrons is oxidation. So losing electrons, oxidation, Leo, the lion, says grr. Grr, G-E-R, stands for the gain of electrons is reduction. So if you gain electrons, it's reduction. If you lose electrons, it's oxidation. Leo says grr. Traditionally, you may have seen this presented to you as oil rig, where oxidation involves loss and reduction involves gain. However, the complicating thing about that is that you still have to remember the whole electrons part. This has nothing to do with oxygens or hydrogens moving. It's about the moving of electrons. Sometimes that might mean hydrogen or oxygen is moving with or against the electrons, but you can get very confused trying to just focus on the hydrogens. Focus on the electrons moving and figure everything else out from there. So you can use oil rig as long as you remember it's the oxidation involves the loss of electrons and reduction involves the gain of electrons. Thanks for watching. Hope this was helpful for you. See you next time.